Welcome back to my channel. In this video, we are going to be solving this mathematical model question, this biomathematics question. And in this question, they say that in a research on population dynamics of mosquito, that it was estimated that the initial population is this. So solution, let us bring out some parameters. The initial population, that is P of 0, okay? The initial population is giving us 2,000. That is when time is 0. Okay, or let me just say P0, and let me call it P0. Or you can call it P0 of time, or you can call it P of 0, anyone you like. Okay, so they say that the initial population, let me call it P naught. The initial population with respect to time, let me call it this. The initial population is what? Is 2,000, and then they now say that over the period, over the time period of 1 month, that the population is now 300 births. So the birth we have over 1 month is 300, while the death we recorded is 100. Okay, so the change here should now be what? The birth, the birth minus the death, which is going to give us 300 minus 100, which will give us 200. Okay, then our rate will now be what? That 200 divided by the initial population, that is 2,000, which will give us 0.1. Okay, now having this, the next thing we are going to do is to derive the formula we are going to use here. And the formula we are going to use here is very simple to derive. You should know that the rate of change of population, the r dt, is directly proportional to the current population. Okay, that the rate of change of population is directly proportional to the current population. This is the modeling of a population that deals with just birth and death, no other constraints. Okay, so the rate of population is directly proportional to population itself. And if you remember that if you remove proportionality sign, then we'll bring in a constant. So we'll say that this is what? The p dt is equal to what? rp. We'll bring in a constant. Now, let us solve this differential equation by variable separable. We can separate them. If we separate them, we see that the p over p itself will now be equal to r dt. Now let us integrate both sides. If I integrate both sides, I'll have that the integral of 1 over p dp, hope you know that this and this is the same, is equal to the integral of r dt. Now, the integration of 1 over p is ln p is equal to the integration of this is rt plus a constant. That is the integration. Now let us take the exponential of both sides. If we take the exponential of both sides, we are going to see that ln crossing here is exponential. So let's take the exponential of both sides. Exponential ln p is equal to what? Exponential rt plus a constant. So exponential is the opposite of ln, so they'll cancel out. I'm having that p is equal to exponential rt plus a constant. So we can separate this by indices to have that my p with time will now be what? Exponential rt multiplied by exponential c. And the exponential of a constant is a constant. So we're going to have that what? We're going to have that p with time will now be equal to what? Let's change it to the initial population because it's a constant. So it's going to be the initial population. Then, okay, let me say exponential rt multiplied by the initial population, because exponential of a constant is still a constant. So we now have that p of t will now be initial population multiplied by exponential rt. So we have gotten our formula to use. So everything we need here is available. So to get the current population will now be what? The initial population, which is what? 2,000 multiplied by exponential our rt. Our r is 0.1, then t. So now they say we should calculate the size at 10 months. The 10th month, that is t, will now be equal to 10, will just be p of t will now be equal to 2,000 multiplied by exponential 0.1 of 10. Or let me say p of 10 rather. P of 10. So therefore, p of 10 will now be equal to 2,000 multiplied by 0. This time, let's give you just exponential raised to 1. That is 2000 times. I hope you remember the the exponential. Exponential is a constant, so which is 2.718 approximately 2.718. So if you multiply the two of them, you see that the approximate number of mosquitoes we are going to have in the 10 months will now be 5,436 mosquitoes in just 10 months. So this is the solution to this particular problem. Let's go to question number 2. I think we have up to 3 or 4 questions to solve. So let's go to question number 2. Here is my dust.